In this video, I'm going to show you how to solve for currents and voltages in a parallel circuit. Parallel circuits have many currents, but they have only one voltage. They've got this source voltage. And this is how, of course, your house is set up, right? There's the same two wires that come in from PGE, roughly, right? Go to your toaster and your television set and your iPod or charger or something like that, right? Okay. They all want to see the same voltage, and many different currents are going to flow out of the individual sockets or whatever of your house. Okay. How you solve this one is a little bit different from a series circuit. The first thing you want to do is you want to actually draw where the currents go. Okay, and I'm just going to label these I1, I2, and I3. Okay, so I1 goes out of the battery, through the ammeter, A1, through this 6 ohm resistor, and then back to the battery. And I2 goes this way, goes through the 4 ohm resistor back to the battery, and I3 goes all the way out here. Okay, and what we're going to do is we're just going to figure out what those currents are. And this is really simple. We're going to use I is V over R, Ohm's law, right? Okay, so I1 is equal to 24 divided by 6, right? Divided by 6 ohms is 4 amps, right? So this guy is 4 amps. Okay, I2 is going to be 24 divided by 4, right? So 24 volts divided by 4 ohms, and that's 6 amps. Right, so this guy is 6 amps. Okay, and then I3 is going to be the same voltage, 24 volts, right? Divided by 8 ohms, right? And that's 3 amps. Okay, so now we're all set. Now the next step is to actually add the currents through the ammeters. Notice that A1, that ammeter, is reading all 3 of those currents. Okay, so A1 is going to read 4 plus 6 plus 3, right? And it helps to draw them so you know which ones go through there, right? So 4 plus 6 plus 3 is 13 amps. Is going to go through A1. Right? Did I do that right? I did do that right. Okay. And then A2 has this current, I2 and I3, as does A6, has the same one. So A2 and A6, those ammeters, are going to just be 6 plus 3. 6 plus 3 amps is 9 amps, right? Okay, so let's go in here. Let's look at A3. Okay, A3 has only, notice that it's off this branch row, so the green current does not go through A3, right? Only this red current, only I2, so that's 6 amps. Okay, let's look at A4. A4 has an A5, A4 and A5. A4 and A5 have only this 3 ohm or 3 amp current going through it, right? And nothing else, right? And then do we have all the ammeters? I think we do, right? Okay, so now let's look at V. Look at these voltages, right? This voltage here, there's 2 ways that I can do this, okay? I can go from this one to this one in the path of the currents and do I times R, okay? So let's go here. Well, here there's a couple currents flowing against us, but there's no resistance because that's a wire. So there's no voltage change. Now we're going this way through this resistor right there, and we've got 4 amps times 6 ohms, right? So we can do V equals IR. 4 times 6 would be 24 volts, right? So that would read 24 volts. I'm doing V equals IR, and then we get back here, and again, no resistance, so there's no voltage change here. So that's one way to do it. The other way to do it is to just trace these things back. If I can get back to the voltage source without going through any resistors, then I must be connected directly to the voltage source, and so therefore it should read 24 volts. Yeah? So that's the voltage of V1 2 different ways, right? V2, let's follow V2. Well, I'm going to go from this side to this side. Do I ever encounter any resistance? I do encounter currents, but there's no resistor in between there, so therefore this guy's going to read 0, right? Okay? Now there's other ways to do it, but basically if there's no resistor, if you can get from one terminal to another terminal of a voltmeter without going through a resistor, it's going to read 0. I promise. It's short-circuited. Okay, that's how you check to make sure your voltmeter is reading 0, and it should. You connect the leads together. Okay. Now in reality, there would be some resistance in this wire, and you might read some kind of voltage there. Okay. But that's it. So basically figure out what the individual currents are through the branches of the parallel circuit, right? Because this is why it's called a parallel circuit, right? Is that there are these currents running in parallel to each other, okay? Figure out those currents and then just add them up as you need to figure out the currents that are going through the particular ammeters, okay? That's it.